example, V as a vector. Okay, what are the components of V? What are the components of V? I have to get its Vx, I have to get its Vy, I have to get its Vz. Some of them will be zero, and most of the time one or two of them will be zero. So that's very important, and that's my I hat, J hat, K hat for V. Q is a scalar. You don't have to worry about it. And then after that, you need the components of B, which most of the time it's in one direction. So oftentimes we just use Z hat. So again, Bx, By, and Bz. And again, is it positive? Is it negative? You have to make sure that if it is positive or negative. If it is I, then you have to look at the conductor. So you look at your conductor that's carrying the current, and in which direction is I, L. Okay, L being the length of the conductor, right? That's L. L being the length of the conductor, and I is the current. So in which direction is it flowing? And from there, again, I have to find the direction. So the most important thing, I say this again, the most important thing in here is finding the components of V or L, IL, and then the components of B, and then you do the cross product. If you don't, if you cannot find that, then you'll be in trouble. You cannot solve it. This is the only way that you're going to solve this. Okay, so that's the definition. Again, we have a lot of examples in the, be it in the test and the worksheets, on the quizzes and so forth. Make sure you do all of these examples about either of the two formulas. After that, we went into some applications, and the most important one of them is the velocity, what we call the velocity selector. Now, the velocity selector, it shows us it's a device or an approach by which we produce a particle that moves with this speed, E. V is equal to E over B. And where did we get that from? It comes from the fact that we have the sum of the forces equal to zero. And we have a particle that moves in an electric field and a B field. So both of them are not equal to zero. So these two are not equal to zero. That means the particle is affected by these two. But what do we do in the velocity selector? We say that FB is equal to FE. Okay, FB is the QVB, and this is QE, so the Q's will cancel, and then I get V is equal to E over B, as I said here. That's the velocity selector. Okay, so if you see, and remember what I said in class, this is the undeflected beam. Okay, the undeflected beam or the zero deflected beam. That's so if it is undeflected, then this is the case, and you can find the velocity from there. So that's the first thing, the velocity selector. After that, the cyclotron, the mass spectrometer. Actually, no, not the mass spectrometer. The cyclotron first. Now, in the cyclotron, or the mass spectrometer, that you have the first part is the selector, and then you have a particle that's moving with V0, velocity V0. Is determined from the V0 here is determined from the initial potential. The initial potential. That's very important. So what does that mean? That means the initial potential, which is EV, is equal to the initial kinetic energy, which is equal to a half mv initial squared EV. So that's how I get my initial velocity. And once the particle leaves the selector, so this is the selector. Once the particle leaves the selector, then it's going to do this. It's going to move, and then from here I get the E over M, or I get the radius M over R. M over R, I can't recall the equations exactly, and I don't have time to do them, but you have to understand that the only thing that you need, what you need to understand is make sure that this is my V0, okay? So that's the initial is V0, and once it gets here, the velocity becomes constant. And then this is circular motion, Fc is equal to mv0 squared over R. So if I wanted to find m over r, then I have to do vc over v0 squared, and fc is equal to what? Is equal to qv cross b. Okay, which is when the particle, this q particle, moves in this magnetic field B. okay, because we have a magnetic field here either in or out. You have to understand that. You have to understand how I calculate M over R. Okay, you have to I just took that over here, M over R. Okay, this is the mass spectrometer. Okay, now I can go back to the. So this is the remember the mass spectrometer. You have a selector that from the selector I get V0 from which is EV is equal to kinetic initial or KE initial. That gives me the initial velocity, and once it enters the field, it moves in a circular motion, just like what we did before. Now the cyclotron. So that's the mass spectrometer. The cyclotron is even easier because in the cyclotron, what do you have? You have a charge Q is moving with some speed V0 given, and then maybe the same speed as that, and then it enters in a magnetic field. So this is a B in or out, and then it's going to do circular motion. Okay, so once it gets here, then FC is equal to mv squared over r. Same idea, except in here in the E over m experiment. The mass spectrometer, we know how to calculate V0, but here V0 will be given to us. That's the only difference between the two. So V0 here is given, and in the previous slide where I showed you V0, you can calculate it from the velocity selector, which is from when the magnetic field. Sorry, not from the velocity, from the initial potential, which is EV. EV is equal to kinetic energy, and the EV, if you remember, the EV is basically the energy because U is equal to EV, potential energy. Okay, that's where we get that from, and this is potential energy, of course, is equal to change in kinetic energy, and then that's how we get the the kinetic energy, and that's what we get the velocity from. Okay, so I think that's chapter 20. What is it? 27. That's all of chapter 27. I know there is a little bit of sort of the equation. There is a number of equations, but they will all be given to you, and you just have to make sure you understand them.